Hi guys, welcome to Northwest Testing Gathering 2016. It's January, and this month we've got Richard Bishop doing a talk on virtualization. Virtualization. I keep getting that wrong. Sorry. Tonight, Claire Foster's not here. She's passed everything over to me now because she's got other work commitments. We'll have a chat about that later on. So I'm just not going to waffle on because I usually do. So I'm going to hand over to Richard, and he's going to start his talk. After this, what we'll do, if you want to take a break, have some more pizza, beer, and then we'll do some lightning talks. Okay.
I'll try and stand out of the way of the screen and not look over my shoulder too much at it. And I've already done the thing that I promised myself I wouldn't do, which is say an because I did loads of those last time I did a presentation here, and when it went on YouTube, my son gave me no end of abuse for it. So I'm going to try and avoid those today. So no, not too much heckling when I drop the occasional or but I've done it again. Anyway, but he'll no doubt count them up for me at the end of the night. So, my talk today is about network virtualization in testing. I know I said one because someone picked up on it. It's about network virtualization in testing. Done it again. So just to give you a little bit of background, I work for a company called TrustIV. We're sponsoring tonight as well. I know the sponsor normally says something, but I never actually thought about what I might need to say. But hopefully the introduction of who we are and what we do is enough. We're an independent testing or specialist provider of QA services. This is the official marketing blurb behind me, but basically we're a company of testing consultants based in Manchester. We've been going since 2005, but most of the people who work within the organisation have actually worked with one another for much longer than that. So we've all come from various different organisations, worked together and finally come together into one company. We're an HP Gold partner, so I'll mention a few of the HP products towards the end. There's a demonstration showing how they're used, but the vast majority of what I want to talk about is relevant regardless of your test environment, the sort of test tools that you use, and hopefully it'll just be a bit of food for thought in terms of incorporating networks or unpredictable behaviours into some of the tests that you do, whether they're functional or performance tests. A little bit of background on me. There's a slightly dated picture of me there with a little bit more hair and carrying a little bit less weight. But I'm head of service delivery at TrustIV, so my responsibility is basically when people go out on site, I help them, support them and make sure they're doing what's right for our customers. I'm also co-leader of Vivit in the UK. For those of you who haven't heard of that, Vivit is the HP Software User Group, or HPE Software User Group as it's now known since they reorganised themselves. I've got 17 years of experience in consultancy, but the bulk of that has been in testing. Basically, I decided to do this presentation based on looking forward to the future and seeing what's coming and what's likely to impact us as testers. And to find some background information for that, I looked at the World Quality Report, which if you haven't seen, it's published in I think it's about July each year, and it's written jointly by Capgemini, Sogeti, and I think possibly one or two other big consultancy organisations, and they go out and talk to testers about things that are happening and things that are affecting them in their business. And these are the statistics that they've pulled together about what the world's likely to look like in 2020. So the key things are we're increasingly mobile, we're increasingly moving to cloud environments, and obviously those sort of things have impacts on networks and how people interact with various different applications. What I've done is rather than focus on all of those bullet points, I mean they're there because I find them interesting, but these four are the ones that are particularly relevant if we're talking about network virtualization in particular. The proliferation in interconnected devices is obviously just happening all the time. The estimates are that there'll be 100 billion of those devices connected to the internet by 2020. The other key thing is the bottom statistic about applications and interconnectivity of applications, so composite applications where you've got an API hosted by Facebook and one hosted by a payments gateway company and one hosted by somebody else, for example. And there's going to be 1 trillion of those by 2020, so all of these APIs that are being published and used for business to business and business to consumer type communications are exploding as well. And obviously there's a significant move to the cloud. 37% of organizations say that they'll have some of their apps on the cloud by 2020. I find that the most unbelievable statistic of all, because I don't think it's enough. I would imagine it'll be much higher than that. And the other statistic there is that it takes typically around 3 seconds for a user to lose interest in your application, be it a phone app or a browser-based web application. People are getting increasingly impatient, and basically that's reflected in their willingness to chuck away an application that they've just downloaded or stop buying from one site because they've had a better user experience elsewhere. So, talking about all of these sort of vision and challenges that we're facing leads me on to test environments. And it's quite common that test environments look pretty much like this, and they don't really reflect production in any way. You may have a tester's PC connecting to an application which may in itself connect to a database. And what you'll often find, particularly at the functional or developer type test level, those could all even be on the same box. So it's not remotely realistic. And your tester is connecting at LAN speed to an application, which is just not what users typically experience. So as you move through the testing life cycle, what you tend to do is add more production-like or more realistic things into your test environment. So for example, you may have multiple application servers, multiple locations, lots of applications talking to each other. And this is more like a real test environment where you have to consider the impact of changes to your application on others and their coexistence, basically. And as you get closer and closer to production, the ultimate goal is that you're running your performance tests in an environment that's ideally the same as production. There's not many companies that actually have the budget to do that, and there's not many who do it. But the closer you get, generally, the higher the quality of testing that you can do. But obviously this is starting to get complicated. You've got testers trying to mimic users who may be using laptops, PCs, obviously, but also mobile devices like tablets and phones and so on. And then you've got potentially remote networks, shared networks with other people, and remote third-party links, which all need to be considered when you're doing your tests. Some of the difficulties that we face as testers are highlighted in red, and basically it's slow networks, lack of access to particular test environments at certain times, or congested networks where you're fighting with someone else. If you're running a test at the same time that somebody else is shipping a whole load of data across the network for another reason, you may not even know that's happening, but it's probably having an impact on what it is that you're doing. There's several ways around this, and two of them I'll touch briefly in the next slide. But basically, service virtualization is one of them, and I'm using service virtualization because that's the big HP term, and we used these slides when we went and did a presentation at their conference. But it could easily just be a stub that your developers have written. So you've got a piece of code that's not there. It's meant to respond with a particular answer to a particular question, effectively. And so stubs, if I'll use the word stub interchangeably with a virtualized service. But obviously network virtualization also comes in. And basically they can help resolve some of the pinch points that you might find when you're trying to get your tests more realistic. So going from that, I'm doing a real world example about something that happened to me on my way down to the conference where we first presented this slide deck. I wrote a blog about it. It's called A Day in the Life of a Forgetful Performance Tester, so that's me. Basically, I was travelling down to London to the conference, and I had a series of meetings for a couple of days before the conference, and I needed my laptop and all the notes that were in them. And I opened my laptop on the train to check, and I realised that my power supply was happily sitting on my desk at home, and I literally had a few hours worth of use, and that was going to be it for the week. So I decided that I'd order a replacement power supply, get it delivered to the hotel, everything would be fine. But it wasn't as straightforward as perhaps this happy path, this simple login, buy something, get it, might explain. I had loads of difficulties, partly due to the fact that I'm sitting on a train and the Wi-Fi is awful, and when that's not good and you pair your phone to it, that's awful as well. Thankfully, I was buying this thing from Maplin, and I don't know whether there's anyone from Maplin here, but if there is, they've got a great site. It's obviously well tested, because no matter how many times I dropped out, every time I hit refresh on my screen, it just picked up where it left off, and it worked. Sage gets an honourable mention, and I know you're here actually, because the payment worked as well, despite this continual disconnecting and reconnecting that I was doing. But as I browsed this app and thought about just how painful it was to do something on a moving train, I started thinking about all the different bits of connectivity, and I had a look at the site after I'd completed the order and just counted up the number of third-party links that my order had actually gone through. There was obviously the network, which is easy to overlook, but basically that's Virgin Trains Wi-Fi, which is routed over EE, badly in some cases, but fair enough, we are moving at whatever speed. The credit checking service that they use is Experian to make sure that there's nothing dodgy going on with my payment. Maplin's obviously got links out to its local stores, because I could see the stock level in the store closest to the hotel that I was staying, and so all of that was working fine. They had links out to Sage Pay for the payments gateway, which in turn must have had links out to MasterCard, which is where my card is, and Marks and Spencer's, because it's one of their cards. So there's all these sort of things, and it's building up a really complex, I mean, just from what you can actually see from the outside, you can start to realise how complex the environment actually is. There's also links out to Shuttle, who do their logistics and their delivery within 2 hours, and real-time tracking, so you see a little map of where the taxi is that's delivering your part. So it was an interesting story, but it just got me thinking about the complexity of the order process for what to us as a consumer may seem like a relatively straightforward process. This is something else that came up at the conference, and a few people talked about 2G Tuesdays, which is something that Facebook have implemented. I'll do more about that later, but these slides come from a report done by VentureBeat and Catchpoint. They've got blog articles discussing this. I think the title is Facebook Sneezes and the Internet Catches a Cold. But the whole blog is talking about how a slowdown or a problem on one site affects multiple other sites. The left-hand side is basically charts showing, it's not as clear as perhaps I would like, but I'm sure the slides will be available later. It shows the page response times for the Facebook application over the period of a few days, and it shows significant slowdowns at certain times. And the thing that's interesting is the slowdowns of this third-party service are then mimicked by, I don't know how many people can see that, but hopefully it'll be on the slides, these 6 charts behind me. Those are basically people who have Facebook links on their sites, and when Facebook goes slow, their site goes slow as well, and you can see the exact same pattern, because their code is waiting for Facebook before it actually renders a page and presents it to a user. So it can be important to simulate things like missing services or slower services or badly behaving services on remote sites to make your tests as realistic as possible, and also do those what-if tests. What if this service gets twice as slow, or half the packets get lost on the way to that remote network? How would my application handle it? So we've talked about some real-world examples, and now I'm just going to go into the sort of concept of network virtualization. So I'm concentrating on these 4 different use cases for network virtualization and where it's potentially useful. And the key benefit of NV is that it can be used to simulate basically uncontrolled or unreliable connections. So it's networks that you have perhaps less control over than you would like. And we did some field tests around this. So these sort of things are the places, looking back to the previous slide, where you may want to use network virtualization. But just before the conference, where we knew we were going to do a presentation like this, we decided to do some field tests. And so we went to Old Trafford on Derby Day, and also a few days before Derby Day as well, to see what the network performance was like in a network where there's nobody there a few days before the game, and see what it's like when 50 or 60 or however many thousand people turn up to watch a game of football and see what sort of impact they have. We were a little bit surprised by our results, by the way, but I won't give too much away. So basically we use this application called Network Capture Express. It's a free download. You can get it on iOS or Android, and you just put it on your phone, and basically wherever you are you can say, I want to time the, it's a bit like speedtest.net or something like that, but it's basically designed for phones. So you time how long it takes to get to a particular site, and in this case we were using the BBC's website because we thought that it's big, it's got a lot of users, it's generally fairly reliable, let's just use that as our test site. But you can obviously pick whichever site you want. And basically the app goes to the site, downloads as much as it can from it, and times how long it takes, and also measures how the network behaves. It looks at how much throughput you get, which is the obvious thing to measure, but it also looks at something called jitter, which is when packets come in the wrong order. It also looks at latency, which is where the round trip response is slower than perhaps would be optimal. And it looks at a fourth thing as well that's temporarily slipped my mind, but maybe that'll come out later.
Packet loss.
Packet loss, thanks very much. Yes, I knew. Oh yeah, Aaron did a lot of the videos later on, so this is Aaron from TrustIV. If anything's wrong in them, and there are 2 typos, and there may be prizes for people who can find them, look out for those later on. So our stats from before the game, it was fairly quiet, and we saw basically, these are the statistics. We saw a download speed of 3.5 megabits a second. We're using an iPhone 4 on a 3G network, which we thought was fairly reasonable, and we were absolutely convinced that on match day, we'd go and repeat the test, and it'd be much slower. Anyway, it wasn't. It was faster, which so at least you have to go into tests with an open mind. But we got 4 and 5 or thereabouts megabits a second, which is about as much as that phone on a 3G connection can even theoretically do. So it was far better than we expected. So it highlights the need to actually take measurements and not just assume it's going to be slower or it's going to be faster. You actually need to go out and get real metrics before you try and put them into your tests. Just to go into a little bit more detail about what we used, as I mentioned, it was an iPhone 4, which has got this thing called HSPA, which is basically one up from 3G, so it's 3.5G or thereabouts. And its theoretical maximum speed is 5.76 megabits a second, that's the download. So we were pretty much getting as good as it gets when we did our test. This is what we expected, and it's always good to go into tests with this is what we think we're going to get, and this is what we actually got, and then try and look at the reasons why you were proved wrong, basically. We thought we'd be looking at high latency, and we didn't get it. We thought we'd find a lot of packet loss and poor bandwidth, and the actual results were much faster. That picture looks much better in the real slide deck, by the way. It was taken by our boss from his balcony, which overlooks Old Trafford, so yeah, he needs a mention for the photo credit. But basically, when we did our tests, we saw no packet loss during the game, and we'd seen 1 to 2% before it. And although the network latency varied quite a bit more than it had done in the earlier tests, it wasn't particularly bad. And as I've already said, the download speed was pretty good. So we weren't happy with these results, so we didn't just keep repeating them until we got the results we wanted for a nice presentation. We started looking for reasons why we didn't get what we expected. And we went on the Ofcom website, which has got a map of where all the cell phone masts are in your area, and they overlay the masts onto Google Street View images. I'm pretty sure there isn't one actually in the middle of the pitch, because I'm sure we'd have seen it. But what this does show is that there are 5 towers within Old Trafford and 11 masts, and so it's pretty well covered. And it may well be that when we did our tests, even though we were standing in exactly the same place, we were on one mast on one day and the decent one on the next. So you can get real variability, and it's worth bearing that sort of thing in mind if you are going to look at any sort of network simulation or throttling in any of your tests. So a little bit more testing that we did on that day. We decided that It'd be good to measure the mobile performance, but it'd also be good to measure the performance of apps that people within the ground may well be accessing. So we decided we've got a test tool that we've written in-house that tests about 600 different websites every day around about lunchtime. And so we get a stat that will show us the performance of one site against another. What we can also do is tell it, go out and do a test every 5 minutes. And so we did that for 4 big betting sites, and we thought they're going to be the ones that everyone in Old Trafford's on, and we'll see what their performance looks like throughout the day as well. The other thing notable about this is the blue sky, and I think until today, that's the last one that we had in Manchester on the 25th of October. So anyone who wants to take a picture of that and imagine it's like that all the time, feel free. So when we did our testing, we decided again we wanted a background test of what network application performance might be like for a typical site. So again, we picked the BBC because it's big, and we requested its mobile page at 5-minute intervals throughout the day. And whilst we saw a relatively decent average, there are a few peaks, and it's worth noting that you're going to get those sort of things in tests. But it's also good to then compare those against the performance of other sites to see if you can find correlations. So the first 2 sites that we looked at were Betfred and Bet365, both of which seem to use a similar technology where they put a holding page up, and our test tool sometimes picks up the holding page rather than the actual page that you as a user get. So we put those on the same graph for that reason. We noticed in particular that Betfred, I know Betfred's a Manchester company, there's no one here from Betfred, is there? I was wondering whether someone might be able to tell us why it was slow until a certain time on a certain day. But up until 10 o'clock, it was pretty slow. We were looking at about a 7-second response time, but it really improved. So it'd be nice to know why, but it was just something that we observed. Looking at the other 2 sites, Paddy Power and Sky Bet, they're a lot snappier, they're a lot faster, and we noticed that, and you know they were generally pretty good. What you see if you put all of them on one chart is, quite frankly, a bit of a mess. So what we've done is we've changed the granularity a little bit to see if we can see a kind of trend line for what was generally happening and what the performance looked like at different times. And bearing in mind our kickoff was about here, it was a really strange kickoff. It was 5 minutes to 3. I've no idea why they started at that time, but it was about here. And whilst we've got a fairly big spike there and one earlier on in the day, our game may have had an impact, but it's not significant. And there's a second spike here, which after the game, which about half time. So we weren't quite sure why we got the results we got. But then we decided to overlay big sporting events from around the country and around the world, and we saw that this slowdown at the start could quite feasibly have been the early kick-off football games at the start of the day. This spike here on Betfred, Bet365 coincides with the start of the Formula 1 Grand Prix, the American one in Texas. And then this spike is bang on when the World Cup kick-off happened at Twickenham, Rugby World Cup. So we can't be sure that these are cause and effect, but at least it highlights the fact that understanding what's going on your environment is critical if you're going to run any sort of tests or try and interpret any metrics that you get out. So that's just a general sort of almost a warning, because we went into each of these tests with preconceived ideas about what it would look like, and we were proved wrong. So the other thing that I decided to look at, and this was earlier on this week, I was in the office on Tuesday, and I've got a 4G phone that I'm reasonably proud of, and it's supposed to be quite fast and impressive. And the people in the office who are on 3G phones and older contracts, sometimes, quite regularly, seem to have better phone performance than I do, downloading videos or doing anything that's network heavy. So I decided to do some tests, and so that was a screenshot of my phone on Tuesday. And I'm doing a test against our site on 4G. And I was getting, as you can see from the screenshot, less than 3 megabits a second, which isn't particularly good. So I went into my settings and I changed my network mode from 4G to 3G. So it's not going to go up beyond the 3G band. And interestingly, I got 10 megabits a second in exactly the same place with a phone on a slower network. So I've tweeted Vodafone about this, and they've not taken the bait, but I would be interested to know what their thoughts are about this, because my theory is everyone's gone out and bought fast phones on a fast network. That network's really, really full, and everyone who's left 3G has effectively meant that the 3G network's now got nobody on it, and so it's working like a dream. But Vodafone probably won't say that, so it would be interesting to know how they respond to my tweets and whines that I'm sending their way. So all it really highlights is the fact that you can't go in with preconceived ideas, because it's quite possible that if you're going to start using these sort of statistics to slow down either functional or performance tests, you can't just say, well, 4G's this and 3G's that. You need to say, well, what about a 4G on a busy day? What about 3G when there's no one on the network? Because those are obviously things that you need to consider. So I've kind of done the preamble about why it's important. There's a little bit here where we talk about the product that we've been using for around 6 months. It's HP has a product called Network Virtualization, which they bought from a company called Shunra about 12 or 18 months ago. So if any of you have heard of Shunra, that's effectively what this is. Oh yeah, it's worth noting that when you talk about the product, you have to put a Z in Network Virtualization, but I put the translation down in the corner for those of us who speak English. So, sorry, I really hope HP don't watch this now. You might want to take that out of the YouTube thing. So, we're obviously interested in the impact of mobile users on an application. So this basically shows a mobile client connecting through the network to a web server and a database server. And the key places where performance can have an impact, where the network can have an impact on performance are obviously in the actual initial connection from one device to another, but the knock-on effects are often seen further down the line effectively. So those four things that I forgot earlier, bandwidth, packet loss, jitter, and latency, depending on how they're affecting your test, your web server may well be using more resources to maintain the sessions for slower users than fast users, because they're keeping connections open for a longer period of time, or each one of them is, and that can have a cumulative effect. But it also has a knock-on effect through the connection pool, which is the thing that the application effectively uses to connect to the database. And that obviously has a knock-on effect on just how busy the database is, because they're generally configured to only handle a certain number of connections. So this chart shows, it's quite an old chart, and I think it's one that Shunra have been using for years, but I can never find a better example of it. This shows two performance tests, and the screenshots basically taken from LoadRunner. So you've got a double axis here, where on the left-hand side you've got the average application response time, and on the right-hand side you've got the number of virtual users in the test. And then obviously that's elapsed time as the test goes along. In the left-hand side, you've basically got an unthrottled network. So your users are basically going in, and these response times here are all pretty reasonable. They're not deteriorating as the number of users increases. The orange line shows the number of users increasing. And it gets up to 500 users, and the response times are all pretty good. This one shows, that's the 500 users, so it's still ramped up in exactly the same way, but this time the network's throttled. And it's not throttled on a whole network basis. Each individual user has its network connection slowed down effectively. Because if you slow down your entire network, say from 100 megabits to 10 or slower, because all your users aren't all using it at the same time, each user can still have more bandwidth to play with than perhaps it would have in the real world. So throttling them on an individual basis, you can see that the response times just get pretty much unusable very quickly. And although the headline says the capacity is less than a couple of hundred users, I think in reality, most of us will be losing our patience about 10, 15, 20 seconds probably, rather than further up the chart. So these are the products that we've been using over the last year. NV Analytics is something that you can download and try, and it's quite interesting. It's got basically a sort of drill down a little bit like web page test for anyone who's used that, or Y-Slow, for example, where you're looking at the performance of different components of your application. And it basically recommends the sort of performance improvements you could do to improve how your application works. You've then got these two products are usually the same box, but basically Test Manager is the tool that you would use to build the different network profiles. So I want this user on this device, on this IP address, to have a 3G connection, for example, or 4G or whatever. NV Server works with Test Manager, and that's basically where if you've got multiple of these Test Manager boxes, you would manage users, you'd manage where all the test results are stored and so on. And then this is the application that's free for everybody and worth a look, because we're all testers and we all like looking at things. So it's great for getting an idea of how your network's performing. And if you do want to complain to your mobile phone provider, then it gives you really good evidence that you can send to them with latitude and longitude, the time, and all sorts of information about why the network isn't as good as the adverts say. So we can use network virtualization in various different ways. And the first one, and the simplest, is basically in standalone mode. And you can all download the trial version and have a play with this. It's quite interesting if you're looking to expand your knowledge. You install NV on a client, and then you can just say, right, slow me down. And that's great until you then need to connect to a network drive, for example, to store the results of the test that you're running, because that's really slow as well. And so you need to think about some of these things. But in its simplest form, that's a good way to get started. And obviously, you're not just restricted to slowing down the traffic from your client. You could have virtual devices attached to your client, virtual machines and so on, and you can throttle those. It's more common to use it in one of these two more complex modes. This is configuring it as a proxy. And the way you would do that is you basically install the software, you start this little executable which runs a proxy server, and then you can route whatever traffic you like through that proxy. These can all be on the same network, so it's fairly easy to configure. You only stick it on a PC and you only need one network card, for example. But you can then route your traffic through a particular port, and you can measure how an application might perform. And that's the sort of thing where if you want to do your own 2G Tuesday like Facebook does, that was on a slide earlier and I forgot to mention it. Facebook have this thing, you can look, they've blogged about it, it's quite interesting. Most of their customers are in the US, but their second largest demographic is in India. And obviously the network conditions in those two countries is vastly different, particularly if you get outside the main cities of India. As soon as you get out into the sticks, it gets really poor. So they have this option where you can, as a developer at Facebook, you go in, and when you turn your phone on or go onto your Facebook app on their network, you've got this, do you fancy being Indian for a day or for an hour or whatever? And they're trying to encourage their developers to use it so that they can see exactly how things do perform on slower networks, and hopefully it'll make them think like the user and develop on their behalf. So sorry, that was slightly off topic because I should have mentioned it about 12 slides ago. So as I was saying earlier, you can configure flows based on the IP address of the client device and slow things down individually. Getting slightly more complex, but it's more usable this way, you can configure NV as a router. So basically, you've got your test devices on the left-hand side of the router, and your application under test on the right-hand side as you look at it. And you can then say, well, I want to give this device 2G or 3G or whatever, and slow things down individually rather than making changes on a proxy server, which obviously affects everyone who goes through that proxy. So this helps you scale up and potentially do more of this sort of virtualization. And then finally, the sort of final product bit is in performance testing. You can install the same thing in LoadRunner or StormRunner, which is their cloud-based platform. And you can then simulate some of your users having 3G loads, some having 3G network speeds, some having 4G speeds, and so on, and look at the impact of that on error rates and performance and so on. So the next bit is a video. This is the bit that Aaron did. Okay, so what we've done is we've basically taken everything we know from all the different network virtualization tools and pretty much all the functional test and test management tools and performance test tools that we use on a regular basis. And we're quite fortunate in that we're partners of HP, so we get to play with all this software without having to buy it. So that's the caveat about this. So basically, I'm going to start that now. What we did to describe our environment, the first example that I'm going to talk through is using UFT, which is HP's functional test tool, and NV with an application called Mobile Center, which allows you to test mobile devices and mimic an actual real mobile device and drive it through a functional test tool. So we automated the functionality of network virtualization through an API as well. So our test tool, as well as starting the test, it also labeled the transactions in network virtualization. You'll see a little bit more about that later. We also did some data-driven tests where we effectively have a table that says run this test first time using this row data, 4G, then 3G, then busy 3G or whatever, and label the tests appropriately. We did this on a physical device that was attached through a USB cable to our test machine, so that effectively drove the application whilst we recorded the infrastructure. And that's never worked timing-wise before, but basically this is the infrastructure. So we've got the tester's PC on the left connected to ALM, which used to be known as Quality Center, Mobile Center connected to a physical device via USB, and that's then connected through our Wi-Fi network effectively through Test Manager, which throttles the test data, and out to our test server, which is a Magento e-commerce box, basically an out-of-the-box installation that we use for demo purposes. This is the point where I have to pause and drink some water before the screen refreshes. It's almost impossible to get the timings right on this. I probably should have said an awful lot more about that. So this is the video showing how you connect UFT, which is our functional test tool, through to Mobile Center. You can see who's responsible for this because Aaron's username pops up in a second. But basically, you type in the name of the Mobile Center server you want to connect to and connect to it, and you can then see the physical devices attached to that Mobile Center server. And you're then able to run tests, the tests that you've recorded in your functional test tool, through a physical device. This is showing selecting the application you want to run your test script through, and in that case it's just a browser. This is selecting the device, so in this case a Nexus 7 tablet. You've got options here as well to either install an application fresh each time or just restart it from scratch so you know that it's at the same state that it was in the previous test. And this shows the application basically starting up on that remote device, and you can see that on your console. So you could have a test lab with dozens of these devices and control it all from one desk. This shows how you can remotely then schedule those types of tests. So initially you need to create a remote host within your ALM, in this case the quality testing tool. Once you've created that host, you can then assign that to run various different tests. Probably should have said something else as well because it's still running on. Here we are. So once you've done that, you can pick the time slots where you actually want to run your test, and obviously scheduling tests to run out of hours is great because you can come in the following day and see how things have gone on. In this case, we're picking a time slot which is 9 PM, and we're picking 2 slots so we can do our 3G and then our 4G test. So that's the time slots created. These are screenshots because it was just far too hard to try and do this as a video. Oh, I've seen a third typo now actually, so prizes for everyone. So this shows the actual execution of 2 tests, 4G against 3G. The screen on the left obviously is 4G. They are different recordings because you can see we left the device options tab open on that. Allows you to zoom in on a screen and see a bit more detail, for example, as well as change the tablet's orientation and so on. And we're using exactly the same business process in each case, so it's the same script doing the same things. But you can see pretty much straight away the 4G device is several screens ahead of the 3G device. And this is all sped up, so it's slightly less tedious to watch. And the only difference between these two is the bandwidth used, nothing else. But this is quite nice to be able to go to a developer with a tablet and say, look, this is slow, and I can show you, this is it on 3G. And in real life, it finished about a minute ahead of the 4G test, finished about a minute ahead of the 3G test. It would have been interesting to do 4G in our office against 3G in our office, or busy 3G at Old Trafford in these tests. And you can do that because the stats from Network Catcher can be imported into the tool if you choose to do that. This shows how Aaron managed to get our functional test tool to call the NV API and label transactions as they're being executed in a functional test tool with the network conditions associated with that test. So basically, the functions we've written are these on the left, and they take the test name, the scenario name, and the network routes and so on. They take the data from here about, we want to simulate 4G good, for example, or 4G bad, and then it puts that into the test and labels each transaction. This is what Test Manager looks like. And there's a pretty good trial that you can download and use and have a look at this if you're interested. The first screen, sorry, I talked about the wrong thing because I mentioned a trial, and that's it. You can't go off script. So yeah, this is what the homepage looks like. And you can see here, these are the completed tests, different network speeds, the times that they ran, and you can then drill down into those and do the analysis. This shows the configuration of a test, which is the client and server IPs, and the type of network latency that you want to, and packet loss and so on that you want to simulate. And this is what the results of a test look like when you start going in and doing the analysis. So you can see the bandwidth in and out and all those kind of things. You also get performance calculations for desktop and mobile use, so you can see how your application performs for different categories of users, and it will give you different performance enhancement tips for how you can change performance for each of those devices. So this is your overall score about how well a page performed, and then these are the recommendations. It's like the sort of stuff you get in YSlow and Web Page Test and Google PageSpeed and all those kind of tools, but it's interesting that it's all in one place, and in this case it's accessible through our test management tools. This is just showing you switching between the desktop performance score and the mobile performance score. So once you're actually within a transaction, you can look at how long it took to download each resource, see the HTTP codes and so on. And you can also say, well, that's an interesting peak. I wonder what that might have been. And the chances are that's some ridiculously large image that marketing decided to put on a mobile app or something like that. But you can zoom in on that and highlight it and take that information to whoever's fault it is and basically beat them up with it. So that's what you can do with that drill down. Okay, the final part of this shows the use of NV in a performance test using load runners. So we've got the same test scenario, so effectively it's our Magento e-commerce application. We're using the community license of load runner, which is free for up to 50 users, so anyone can have a go at doing this if they're interested. Basically, we've got a test where we've got 36 normal virtual users in total, and then in one test we've got 2 of those are slowed down because they only give you a 2 network virtualization user license, so it's their way of basically making you buy the others. So this is our test setup. We've got our tester's PC, which is a load runner controller, a load generator which has the network virtualization agent installed on it, and our test application. So we're using the free to use version, which is the one with only 2 NV virtual users. Any of you who's familiar with load runner will probably know this sort of chart, but basically you've got at the top, you've got the 3 different scripts that we're running. We've got one that's literally just hitting the home page, another script that's actually going through a business process and buying something, basically putting it in the cart and checking out. And then the third one is that same script as the second one, but with different network conditions. On the left-hand side, all of our users are unthrottled. They're all running at the same speed. And in the right-hand side, we've got exactly the same scenario, but the two users in the final group, which represents a script that's been network throttled, are running at 3G speed. So when both are started sort of at the same time on two machines and then glued together later, so you don't have to watch both videos. But as the tests start, you see the number of users increasing in this column here. So that's the number of running virtual users. It just goes up as the user load builds. And they both ramp up at exactly the same speed to 64 virtual users. Can't remember how long this takes in speeded up time. There we are. So they've completed their ramp up now, and these two groups of users are both running. And so any minute now, you'll see the third group of users come in and just add that extra 2 user load to the test that we ran. So on the left-hand side, you're just adding 2 at LAN speed, and on the right-hand side, 2 at 3G network speed. Trying to watch it happen, but it's quite hard to make out on that screen. But very quickly, within the time frame of those 2 slow users being added, we start to see errors in the right-hand side. Up in the top corner is basically the status of the test that you're running in Load Runner. And as soon as you start to see red, that tends to be when your boss comes and looks over your shoulder and says, what are you doing wrong, basically. But what's happening in this case is we're starting to see errors across all users, and it's not just those 2 users who are on the slow connection. They're having a knock-on effect on all the other users. And if anyone's got Load Runner and wants to see the results, we'd be more than happy to share them, because they're quite interesting, because every single user starts to experience errors and timeouts and so on. Price for a typo on this slide as well. Our test scenario completed without errors. So, okay. Oops. Okay. So basically, obviously, we've been talking about using network virtualization in the application lifecycle and looking at some of the pros and cons of it, basically. More pros than cons, I would hope you'd agree. But basically, it gives you the option to test composite and cloud applications more effectively than you're able to do in just a standard environment, because you can start looking at the performance impacts of putting servers in different places, even if they stay in the same place, and just virtualize the fact that they're somewhere else. You can obviously optimize the performance for users of mobile or high-speed LAN devices and so on. And it's all about optimizing that mobile user experience, because there's going to be 100 billion devices online in less than 5 years now. So all of those people are going to, or all of those devices are impacted by some of the changes that are happening. And obviously we need, as testers, to incorporate these things into our tests. So although I mainly talked about network virtualization, service virtualization or stubbing is important as well. Obviously the 2 sites that we've looked at, and it's relevant regardless of what industry sector you're in, but retail has got particularly fickle customers who will just go somewhere else that sells the same product if the website's faster. But those sites are also very vulnerable to slow users consuming resources. That person who's browsing your site whilst they're looking at the product that's physically in their hand is probably having more of an impact on your site than someone at home who's actually buying it. And the other thing I think to remember is that people aren't loyal. People will go anywhere, and so the user experience is obviously more important than ever. The other thing that we found is that betting sites are vulnerable to variations in network performance, and obviously the sort of thing that needs detailed testing, because particularly with these applications where you can have a bet that's ongoing and then say, right, I want to cash in now. Those sort of things where it's particularly time critical, are the sort of places where you really must take this sort of thing into account. Because if someone says, well, I tried to cash in my bet 2 seconds before the other side scored, and your site didn't let me do it, I don't know where they'd stand, but it's the type of thing that creates a bad user experience, and obviously you want to avoid. So, thanks for listening. I should have said at the start, feel free to ask questions throughout, with the exception of the video, but I didn't do that. But now's a good time if you do have any questions or things you'd like to follow up on. Thank you.